Welcome. I'm Bill Wake. We're here working on a Kaleidoscope project, and we're just about to wrap it up. So I thought I'd do a little code review of this week's work and show where we're at. So what we did this week was, first thing was we made Kaleidoscope pictures from a live camera feed. So as you move your camera around, you get a different Kaleidoscope picture. Then we did something to capture images to the photo library. So if you saw an interesting view, you could take a snapshot. Then we did a little background work. We activated SwiftLint and cleaned up all the errors that had accumulated from me not putting that in before. We parameterized some tests, and then we used that to improve the way we search for things. I'll say back and forth rather than instantly wrapping around, and I'll come back and explain that a little more later. And then finally, we added a setting for the number of repeats. You might think of it as the number of mirrors, but it's really the number of segments that get repeated in a circle as it processes it. We'll start with the camera model. So if you want to use the camera, you have to set it up. Notice this class, AV Capture Video Data Output Sample Buffer Delegate. I mean, that sounds like Java. But it says we're going to provide a capture method. And we'll see it down here. So we'll get to how that gets activated, but that's the overall goal is we want to capture this, get it into JPEG data, and send it to our screen or send it to our library. All right, so what this class holds is pretty simple. It's just a public error, a string, and a public image, a UI image. And then to do its job, it sets up a capture session and sets up a queue to work with the camera. So when you start, it asks for permission. You've probably seen a pop-up when an app is going to need access to the camera. This corresponds to that. Then we set up the actual capture session. So we do some configuration of it. We're saying we want to capture video. And once we've got that, then we're saying, okay, I want to put some output. Well, set the sample buffer delegate to this class and run it on the camera queue. And that triggers the capture output every time there's a frame of video. All right, so what happens is it gives us the sample buffer, which is a very low-level video buffer, and we can interpret that as an image buffer, which we can convert to CV image, which I think is core video. We have to trace our way through the history of video, I guess, or images. We get that core video image. We treat it as a pixel buffer. Then we do a CI image, and I forget, core imaging maybe. That converts it to one type of image, and then from there we can convert it to UI image, which is kind of the target we have. Once you get that UI image, you can ask it for JPEG data. I just did a kind of moderate compression. And once we have the JPEG data, we can build a new image with the JPEG data. Now you might think, wait a minute, we had a UI image and we're creating another UI image from the JPEG data. Won't it be kind of slow to convert it to JPEG and then copy it into a brand new image? And the answer is yes, it can be a little slow. We tried this with ping data at one point, which is not a great match for photo type stuff. And it was pretty slow and created pretty big files, and there was a noticeable lag as it was doing it. But you might wonder why we're doing it in the first place. Well, that's the comment. We copy it because if we don't, we're trying to retain the video buffer, and it wants to control the video buffer. It's just giving it to you for the duration of your method, and it wants to reuse it for the next video frame or one of the next ones. So if you don't copy this image into a new one, then you don't, you're going to lose your video buffer before you get a chance to display it. So a little work went into figuring that out. All right, and then the rest, you can start a session, stop a session, or tell if it's running. We use that to keep track. If you move off the video feed tab, we want to stop the camera. At least we keep it connected, but we're not actively doing the video stuff on it. So we can tell it to stop the session or restart it when we reconnect to the tab that has the live camera feed. So once you have this object that eventually produces error and or image, all right, then we can display that. Okay, and let's see, where we're doing that is we're using that camera model. We look at the image, and that's the image that goes into our Kaleidoscope view. So all that mechanism to create the image, and now it just looks like a normal image on a UI view, okay, and goes from there. All right, so that took kind of a day and a half, couple sessions anyway. Well, a day is 2.5 hours ish for us. All right, and then once you have this thing, well, let me demo it. I've got it running on my iPad, and the feed you're seeing is just looking around my room. There's, I don't know, there's some, you probably can't see there. There's a bookcase and some wall and my dulcimer, I think, and then I don't know what's over on that side. Another bookcase, but we've got the views. They're all coming from the live camera. Okay. Now, the next feature we added is if you tap it, notice the image kind of makes a copy and sends it off to the bottom corner. And I don't know if I probably don't have my volume up. Try that again. We get a camera sound. And then I'll do it. I don't know. I just think my floor looks so cool like this. I'll do that one too. All right. And I can go in my photo library. So in the photo library, you can see various pictures I took, and I think that floor one is kind of the coolest. It's just a brown and white nothing floor, but it looks very cool when it's in the kaleidoscope view. All right, so how are we capturing? Well, that comes down to capturing view. So capturing view, basically there's a pattern you use with this that you say content, and then on the tap gesture, we say capture the content. And it's the same content in both places. So this is kind of a little helper class to do that. But, well, I guess what we're seeing is you tap and we do a capture, and then we're going to capture the current contents of our kaleidoscope view, and we'll animate that. Basically, the scale changes, so it shrinks, and then the offset changes, so it goes off into the corner. All right, and the way you see that is that we show that captured image at the scale and at the offset. And so this with animation says, hey, when I change the scale from 1 to 0.1, I want you to somewhat slowly animate that. I mean, across 1 second. And same thing for the offset. It starts off at the center, and then, I guess 0. It starts off no offset, and then the offset works its way to the corner of the screen, and so it does that. So X and Y both have the offset there. All right, so that captured is the image that's sliding across the screen. And then the capture method itself, we really just create a UI image. We're given the content of the view, so we can use this image renderer class that turns a view into an image. We capture the image. We'll see that down below. We play a sound to get the shutter sound. It's just a system sound. And then we set the captured image to the UI image that we captured, so we can do the animation. And then captured image, we're just, the big thing is it's writing to the photo album. So there's a pretty straightforward method that says, write this image. When you're done, call this object self and this method done writing photo. And that's extra context you can pass. We don't need it. But calling done writing photo, we just say if there's an error, let's put up an error message for it. So pretty straightforward there. Okay, next thing was SwiftLint and parameterized tests. Well, SwiftLint, basically it complains if you put like extra lines in, or your formatting's not good, or you've violated certain things. It detects missing accessibility labels. Now in this case, because we're capturing it and not doing anything with it, we don't really need an accessibility label on it here when we capture it. So I told SwiftLint, hey, don't try and do that. But in general, there were a number of issues, where I'd formatted things poorly or things like that, whatever kind of complaints it has. I remember I had this on one line and it likes it on 2 lines. Little things, but it makes the code more consistent. And then the next one after that is this trace back and forth idea, and we'll use parameterized tests there, so I'll show that as well. But I'm going to explain that one a little bit. So the way whenever we have an image, like this one's a photo, and it could be a live camera feed as well, we want to show fractions of this. So we basically take a piece of pie and we cut out that piece, and then we reflect it across that vertical line, and then we repeat it around so it's a circle, and that's how we get those cool images. But where are we going to show? Well, we do this in 2 dimensions. So one is the x-axis is just corresponds to 0 to 2 pi. So we're measuring the rotation of the image, when the rotation of this physical screen, the yaw, just that side, or I don't know, steering wheel rotation. 0 to 2 pi ranges. Well, we say let's just take the x-axis from 0 to halfway across, okay? And it's halfway across because we know that for a big enough piece of pie, it could go out to here, and we would be off into the white space surrounding it, and we don't want that. We learned the hard way that we really don't want to do that. Now, we could get more accurate if we said, this is clearly a function of the sine and the cosine or whatever, to say, what's the width of this piece of pie? We could slide it over to here. We looked at doing that. And it looked like a little more work than we wanted to spend. So we just took this simpler one that says range from here to here horizontally, here being the middle point. And then vertically, we use a sine wave to bounce up and down. So I think we have 3 repeats, so we're bouncing up and, just kind of up and down like that, so that every picture is a near neighbor of the one, corresponding to the previous angle. All right, and what we were doing was this. We would go and then hit the halfway point and then start over. So we would immediately jump back here. And you could notice that there was kind of a discontinuity from the edge of this jumping back over there. And so what we did instead was we modified this x-axis stuff. The y-axis stuff is fine the way it was, but the x-axis stuff, we modified it so from 0 to pi, which is halfway across a circle, we went this far. And then from pi to 2 pi, the other half, we oscillated back. Okay, now we're still going up and down vertically, but just as far as our x-axis point. So it has the effect that we're doing this back and forth, and there's never a moment where we jump to some other portion of the scene. Okay, and that's going to show up in our angle tests, or our angle method. And here, this EG test package is a little parameterized test package I put together, but what we're doing, first off, we defined a method that takes any radians, which can be, normalized, like you can have 0 to 2 pi, or you could have, plus pi, minus pi to plus pi, or something, but, 2 pi around is a circle. So we said, we'd like to have positive radians, 0 to 2 pi. And so these examples say, like, if you have 2 pi plus pi over 2, well, the 2 pi's should come out, and it should just be pi over 2. And then 6 pi is really the same as subtract 2 pi's until you get 0 to 2 pi, and it's 0, okay? And then, negative numbers and so on. But they all had basically the same test, like this. And so a parameterized test worked very well. All right, so that was a little helper function. Then the x offsets. Let's see. So these are basically increasing: 0, pi over 4, pi over 2, 3/4 pi, pi, 5/4, 6/4, 3/2, or 7/4. Okay, so just saying, at 0, we expect to be at 0. At pi, we expect to be halfway across, which is 50. And then in the middle, pi over 4 is 12.5, so 1/4 of the way. Pi over 2, 1/2 the way, 25, and so on. And then working their way back, so 0, 12, 25, 37.5, 50, 37.5, 25, 12.5, back to 0. And so we get that oscillation. And it worked out okay doing this. I think one Well, there was always a little bouncing back and forth to make sure we validated the numbers, kind of. I wouldn't say it was kind of it was not a strict test driven, instead I did things to change code and say, I expect this kind of backwards, do it right in the expectation second. Um, yeah, it just seemed to work out easier because we've changed this about, I don't know, three major times, and one of those major times was just probably 25 minor times inside it. Okay, but at any rate, I like this scheme. I think we could develop the scheme that would actually get a little more of the image, maybe some sort of wrapping or something. But um, I think for this version, it's fine. You don't notice on the photo and go like, "Oh my gosh, where's the rest of this?" It's just not visible with any sort of real situation. Okay, and then the last thing is we added a settings tab, and let me show that. Okay, so it's just a new tab, and it just tells how many repeats of the image do you want. So we were at 10. I'm going to put it back down all the way down to 3, and then take a view of our photo. You can see 3 distinct sections there. So it's a piece and the reflected piece, so a 60-degree piece reflected, and then all that repeated 3 times. And as I rotate, I can see that image changing, but it keeps that 3-piece angle to it. All right, so you have that control of settings, and that was actually pretty straightforward. We added a new tab. We had an experiment tab. We'd done a lot of kind of manual testing of spikes and things like that. We took that out, trying to get this more production ready, and we have a settings view, and it's just that just sets up a tab button for it. If you click on the little widget for it, you go into the settings view class, and the key thing there is it's really this, the repeats. How many times do you want to repeat that picture going around? Because we're doing it with a slider for whatever reason, I don't understand. They've defined slider to only work on doubles, not on ints. And so we set up a kind of shadow binding. We have this repeats for editing purposes. It's a binding, and if you get a value, it pulls the value from repeats and turns it into a double. And if you set the value, it turns it back into an int and stores it like that. So this just enforces that the slider that wants to play with doubles actually updates the binding to an integer value. And there's not much to this. There's a little bit of a title. There's a slider that's restricted to 3 to 20 and steps by 1. And we don't have to do anything else really. It because it's a binding, as that slider moves, it changes the number of repeats, and that gets updated right away. Okay, now this is a binding. It's coming from the content view, holds the real object for it, which is this one. And it would be a state like these other two, but we said, it makes sense that if you leave the app, you completely close the app and reopen it, you'd like to have the same value in there for your repeats. You chose it, let's keep it. So it's put in app storage under the repeats variable. And with that, you get all the persistence of that in the app storage, which is your settings basically. You can put some things in it, but not anything too big, but settings are perfect for that. All right, and so with that, we get that view for there. All right, so this has been a fun project for me. It's always nice to do something a little bit graphical. You kind of get to see immediately what happens. It was kind of surprising to me how little I could do TDD with this. So many things were just like configure it. I think the camera model is kind of an example. The real interface that I want to work with is I need an error string if there's an error, and an image string if there's an image, or an image UI image. Everything else is all this detail that's just like, how do you go ask for permission? Well, create a dispatch group, do blocker enter, mark request access. That will let the system request its access, and you wait until it's there, and so on. This is just a pattern I mean, we either found this in the Apple documentation or Stack Overflow, but just like this is just the way to do it. Okay. And same thing, setup session. You set up this thing to capture from the device. You've got to create a session for it. You have to attach inputs and outputs to what you want. You have to set up the buffer delegate if you want to do capturing. It's just all kind of driven by arbitrary stuff. It's not formulas or anything. The only place we had real formulas was in these angle computations for X and Y offset. Here you can see the sine wave in the Y offset. And the tests did help us a lot there, I think. Part of it was we had bad expectations at some point, and we finally straightened all that out. And then when we wanted to change the process, it was pretty easy to do that. I think you catch yourself with the wrong answer sometimes, and you realize like, oh no, it has the right answer. But it was pretty straightforward to do those changes that are really formula stuff that fit very well. The view stuff and the low level access don't really fit so well. You could wrap it. I just didn't. I don't know. I mean, none of this is very big. Even that camera model's, I don't know, is it 100 lines even? Just over. There's nothing that, I don't know. Everything going on is just kind of like accidental data, or what accidental complexity, I guess, from Fred Brooks' phrase. So a lot of manual testing and not much TDD. Unusual combination for me, but it felt like the best way to do it. I could have plugged in an object that would substitute and provide me an error and image as kind of a fake object or a mock object or something, but that's not the part I'm worried about. The part I'm worried about is making the camera work. So, and I don't see any point in mocking that out to just say, you're doing whatever this says you have to do. So that's the way we took it. All right. Well, with that, I'm wrapping this project up, at least for now. I may decide to put it in the app store at some point. I think it's pretty close to ready for that. I need to handle dark mode, and I need to check a few other things. But it's basically wrapped up as far as Twitch. And then next week, I'm not sure what I'm doing for the next session. I'm kind of torn between some friends have been doing some examination of Wordle, and I kind of stayed out of that, and I kind of want to get in that. But I also have the sort tables project I worked on a couple years ago. I'd like to modernize that and really build my understanding of the new way that iOS 17 does models. They've changed the model view stuff for that. All right. Well, thanks for joining. Have a good week and take care. Bye-bye.